Here are selected homework from section 4.1a. So let's start with number 1. We have to apply the appropriate integral rule to find the indefinite integral. So first, we see that we may need to use a power rule, but here's an important reminder. Make sure that your variable is sitting in the numerator before applying the power rule. Just like the derivative power rule, we need to make sure our variable is sitting in the correct place before we can apply the power rule. So think of -9 as you would with the coefficient. It's just going to stay there. We're going to apply the power rule for x to the -4. So we add 1 to the exponent, becomes x to the -3 over -3 plus c. Simplify, we get 3 over x cubed plus c. Okay, number 3, we want to find a way to combine the terms so we can get rid of the parentheses and treat each like a separate. Once we split everything up using plus or minus, then we can treat each term as a separate problem with a specific rule. So we follow this out, we get x squared minus 4, so now we can apply the appropriate rule for each. This is power rule. X squared becomes, integral of x squared dx becomes x cubed over 3. 4 is a constant, so the rule for constant is a constant times x. So we're always going to increase the degree of our exponent by 1. Okay, finally, plus c. Okay, number 9, we want to, just like with derivative rules, if we know we want to apply the power rule, we always want to try to rewrite our problem, our radical form, convert radical form to exponential to rational exponents. So cube root of x can be rewritten as integral of x to the 1/3 dx. So we apply the power rule. Okay, variable sitting up in the numerator. We have our exponent sitting here. So the rule is we add 1 to this exponent. So 1/3 plus 1, the same thing as 1/3 plus 3 over 3, which is 4/3, and we divide it by that number as well, 4/3. So this 4/3 need to be flipped so it can be brought up to, so we can get rid of this complex fraction. So we get 3/4 x to the 4/3 plus c, and we can bring it back down to radical form if you would like. Then it would be 3 cube root of x to the 4th over 4 plus c. Okay? But for the most part, either form will be acceptable. Okay, number 11. We want to find a way to combine variables if we can. So this is x to the 1st, this is x to the 1/2. So if I'm multiplying bases, if I'm multiplying like bases, I can add exponents. So 1 plus 1/2 is 3/2. So we're able to simplify, but we still need this x sitting up in the numerator if we want to apply the power rule. So bring the x to the 3/2 up. We get x to the -3/2. Now we're ready to apply the power rule. Add 1 to this exponent, -3/2 plus 1, -3/2 plus 2 over 2, which is -1/2, so we divide it by that number, -1/2, the new exponent that we just found. Okay. Flip this to bring it up to the top, so we get -2 x to the -1/2 plus c, and we can bring this back down to the bottom, so -2 over x to the 1/2 plus c, or -2 over square root of x plus c. All right, number 13, 1 over 2x cubed dx. I'm going to, the 1/2 is just a leading coefficient, and this x needs to be brought up to the top if I want to apply the power rule. So bring the x up to the top, so we get 1/2 x to the -3 dx. I'm only going to apply the power rule for x to the -3, so I get x to the -2 over -2. I added 1 to this exponent. So then simplify this, I get -1 over 4 x to the -2 plus c, and then this x to the -2 can also be brought down to the denominator. We don't want negative exponents in any of our answers. And finally, the plus c. All right, 27. We saw this with the example from the notes. If we have a fraction, but there's only one term in the denominator, we can split this up, rewrite this as the sum of 3 separate fractions. So I'm going to split this up, and I'm going to rewrite the square root of x as x to the 1/2. So my 3 separate fractions I'm going to consolidate, combine, and I can subtract exponents to combine. So 2 minus 1/2 is 1.5 or 3/2. 1 minus 1/2 is 1/2. And then this x to the 1/2 I can bring up to the top if I want to apply the power rule, so x to the negative 1/2. Now I'm ready to apply the power rule for each. Add 1 to each exponent divided by that new exponent, which is what the power rule says. So 3/2 plus 1, or 3/2 plus 2 over 2 is 5/2. Okay, 1/2 plus 2 over 2 is 3/2. Negative 1/2 plus 1 is 1/2, so we divide by the new exponent. Flip, bring all the fractions up to the numerator. So we get 2/5 x to the 5/2 plus 2/3 x to the 3/2 plus 2x to the 1/2 plus c. And you can also rewrite your answer using radical form if you'd like.